Right, this is our last lesson in Unit 6, Lesson 6.3. We're still working with triangles and how do we prove triangles are similar. We'll learn two new theorems in this lesson to show that triangles are similar. The first theorem we'll look at is the side-side similarity theorem. It says that if the corresponding side lengths of two triangles are proportional, then those triangles are similar. So if just focusing on the sides of the triangles and nothing with the angles, if we can show that each of the sides are proportional to their corresponding sides in one triangle to another triangle, then we know that those triangles are similar. So it's finding the same ratios like we have been, and it's finding them for each of the sides, and if we find that they all have the same ratio, meaning they're proportional, then we can say those triangles are similar without having to look at the angles at all. In this example, we're told to find the value of x that makes the triangle similar. And so what it's giving us the side lengths, but two of the side lengths are expressed with x. And so we would figure out, okay, what x value is going to make these sides all proportional so they have the same ratio, which then would show that these triangles are similar. So it's kind of a different way of approaching this to show, okay, what makes these triangles similar? What value is going to make that true? To solve something like this, because you're looking for what's the ratio for each of these sides, we need to compare two of the sides we know, like AB and DE. Okay, AB and DE, those are two corresponding sides which have a ratio of 4 to 12 or 1 to 3. And then we need to find what x is, and so we need to involve x. So we can look at BC and EF. BC here and EF here corresponding. And so that ratio would be x minus 1 over 18. And so this is the proportion I would set up, and this is going to help me solve for x. So I'd cross multiply. 4 times 18 is 72. 12 times x minus 1 is 12x minus 12. And then add 12 over, divide by 12, you get x is equal to 7. And so that's the value of x that is going to make these two triangles similar. And let's check to make sure that's true. BC, if x is equal to 7, is 6, and DF is 24. And so we can check that they all have the same ratio, right? Which means that they're all proportional. So again, if AB over DE is 4 over 12, and BC over EF is 6 over 18, those check out. Like those are the same ratio. 1/3, or we could cross multiply. 72 equals 72. And same thing for AB over DE and AC over DF. 4 over 12 equals 8 over 24. Those are both the same ratio, reduced to 1/3. Or 96 equals 96. And so that's showing, once we plug in x, that all these sides are proportional. And so we found the value of x, plugged x in, and then that showed us, once we plugged x in, that showed us that they did all have the same ratio. And so when x is equal to 7, these triangles are similar by the side-side-side similarity theorem, because all of the sides have the same ratio. So we don't even need to talk about their angles. If we know all three sides and can show that they're all proportional, then we know that the triangles are similar. The other theorem in this lesson is the side-angle-side theorem. And it says if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of those sides, including these angles, are proportional, then the triangles are similar. And there's one part in there that's really important, where it says the lengths of the sides, including these angles, are proportional. So notice how the word angle is in between side, angle, side. When you're looking at the figures, the sides you need to be looking at need to be the legs of that angle. Okay, so like here's the angle x and here's the angle m, and those are both congruent. So the sides that you need to compare to see if they're proportional are xz and mp and xy and mn. Okay? You can see that down here as well. You need to choose the sides, look at the sides that are including these angles, right? You can see how these sides have this angle here, and these sides have this angle here. We're not going to look at ZY or PN because those aren't a part of this angle here. Okay? So you need to make sure you're looking at the side, angle, side, angle, side. So how do we use that theorem to show similarity? how can we show that these two triangles are similar to each other? Well, we first want to look to see, do they have a common angle? Right, they do. R and N are both right angles, so those are congruent. Okay, but then we need to see, are their side lengths proportional? And so we look at their included sides here, so 28 and 21, 24 over 18. And so we would compare the ratios there, 24 over 18, 28 over 21, and determine, are those do those all have the same ratio? And they do, right? So we see that angle R is congruent to angle N, and SR over PN equals RT over NQ equals 4 over 3. Okay. So 24 over 18 and 28 over 21 all reduce to 4 over 3, and so they have the same ratio. And so we can say that these triangles are similar because their angles are congruent, R and N, and their two sides that are including those angles are proportional to each other. So we don't have to look at the third side, we don't have to look at any of the other angles. We have two sides and an angle that's included in there, and so the side angle side theorem says that these two triangles are going to be similar. So that's the two theorems we'll focus on in this unit. We'll look at a couple more examples to kind of flesh that out more. All right, so we're going to look at example 9 on page 13 in your notes. It's in the third section. We're going to look just at example 9 because we can actually learn about both theorems using example 9. So it says to explain how to show that the indicated triangles here are similar, okay? XZW and YZX. How do we show that those are similar to each other? And we can actually do it two different ways, using either the side-side-side theorem or the side-angle-side theorem. So we're going to look at both of them and kind of see what's different between them. So let's start with the side-side-side theorem. So if we're looking at the all three sides of the triangle, and we're trying to use that theorem to determine if these triangles are similar, we need to show that all of the sides are proportional. They have the same ratio. So I'm going to want to match up the corresponding sides and look at their ratios between each other. All right, so the first sides I'm going to compare are ZY and XZ. And those are actually just the smallest, right? I chose those because this side ZY is the smallest side of this triangle, and then XZ is the smallest side of this triangle. So I know that those are corresponding. So I'm going to compare those. So ZY has a length of 9, and XZ has a length of 12. So it has a ratio of 9/12, or if I reduce that, that's 3 over 4. So the ratio between ZY to XZ is 3/4. Now, in order to use the side-side-side theorem, I have to look at all the other two sides as well, find their ratio, and then see if they're all the same. And that will tell me if they're proportional. So that's what we'll do next. All right, so comparing the other sides, XZ to WZ and XY to WX, I find that they all have a ratio, a common ratio of 3/4, of 3 over 4. And so that means that these sides are all proportional. We could write a proportionality statement like this. All right, so this proportionality statement here is telling us that the corresponding side lengths between these two triangles are all equal, and so they're proportional. And what that means then is using the side-side-side theorem, because of the side-side-side similarity theorem, these two triangles are going to be similar. And so this is how I could show that these two triangles are similar using the side-side-side similarity theorem. We can say that triangle XZW is similar to triangle YZX. Okay. That's our reasoning for that. And so that's how I would use that theorem in order to show these triangles are similar. Next, I'm going to use the side angle side theorem to show that these triangles are similar. So I need to show that one pair of angles are congruent and that the side lengths including those angles are proportional. Now, from the previous side that I just, the previous example we just did where we're using the side to show that these triangles are similar, that can actually help us here that with the fact that we already did that, because we've already shown that zy and xz are proportional to xz over wz. So these sides are proportional to these sides. You notice that xz appears twice because it's a part of both triangles, right? It's right here. It's a part of both triangles there. And so those are proportional to each other, and they're including the angles that we know right here. And so this is part of the side. These are the two sides. I need to show that they're proportional. Okay? And so those sides are proportional. We saw that from the work above, that they all have a ratio of 3/4. Right? That's how we know that they are proportional to each other. So now I need to show, are the angles that are included within those two sides, are they congruent? So you'll notice that the angle here at z, or xzy and xzw, are both 90 degrees, right? Because this one over here we're told is a right angle, it's 90 degrees. So it's supplementary to this angle over here, so it is also 90 degrees. And so those two angles are going to be congruent to each other. So now what I've shown is that these two angles are congruent to each other. They're both right angles, or 90 degrees. And the sides that are including those angles are proportional to each other. So by the side angle side theorem, and so that's how I could use that theorem in order to show that these triangles are going to be similar. That two pairs of corresponding sides are proportional, and specifically the ones that are including the angles here, and show that those angles are congruent.